Hey everyone, and welcome to the video. Today we will be doing left shifting on the port C register. The operator we're going to be using today is this one here, and it's used for shifting left. We will look more into this when we look at the code. But suffice it to say, essentially what happens is that we load a value of 1 into RC0. So we activate the first LED, we then shift the bit within the 8-bit register until we get to the part here to pin RC7, which is the 8th pin, and then we restart sequence. So basically we've got our schematic here. We've got the PIC18F45K20. We've got our 20 MHz external crystal connected with two 18 picofarad capacitors. We've got our green bar graph LED here connected. So we need to change this to 15 ohms. So as this is a 3.3 volt mic controller, we then get 3.3 volts on these pins. The bar graph LEDs themselves will use 3 volts approximately. So then we need a low value resistor to be able to see them illuminate enough. Now obviously in simulation it may not matter as much, but if you're using hardware then it will matter. So 15 ohms is a value I've calculated previously in the first video. So that's the value I'm using here. We've also got pin RE3, which is the master clear pin, pulled up to VDD. The reason for this is active low. So in order for the microcontroller to operate, we need to have it pulled up to VDD, which in our case is 3.3 volts. Also, if you're using hardware, don't forget to connect the power supply pins. So before we set the code up, I just want to go over how the code works. So we can see we have 8 executions. We load the 8-bit register with the first value, 0x01. And then when the code loops back in the second execution, the bit has been shifted to the left, as you can see, from D0 to D1. The value then becomes in the register 0x02. In the third execution, we shift the bit again, 0x04, and this continues until we get to the 8th execution, where the last bit, D7, or in our case C7, is enabled, and then we get the value in the register 0x80. And when this happens, an if statement that activates, that then reloads the register with the first value, 0x01, and the cycle continues. This will be better explained in the code. So I've got a demo example set up here, which we'll look at later, but I just want to show you how to set the project up. So we go to File, New Project, Microchip Embedded, Applications Project, Next. We're using the PIC18F45K20. Click Next. We're using XC8 version 2.46. So as this is the third episode, I'll call it T3. So just make sure you've got set as main project and open MCC on finish. Click Finish. So I'll open MCC in a moment. So you want to go for MCC Classic Content. Click Next. Okay, so we've got our graphical interface uploaded. So the first thing we want to do is set up our system module. So you can see we've currently set it as 1 MHz. That's the default for MCC, and we want to change that. So for oscillate select, we want to select HS oscillator, as we're using an external crystal. The external clock is 20 MHz, and that's all you need to do for this bit. Interrupt module, we're not using that, ignore it. Pin module, you can see we've got no pins configured at the minute, so we want to go into pin manager grid view, pin module, GPIO output, as we're using LEDs. Go to port C and just activate all them in the output section. So after doing all this, we just need to click generate here and give it a moment. So we got generation complete. And then to exit MCC, just click this button once. And it's gone. So from this point on, I've set up MCC. So if you want to make the project yourself, you can do it that way. I'm just now going to copy in the main code from my other project, and we can go over it. So in this exercise, we will see how the contents of the lat_c register will be left shifted by a value of 1, and then we will observe these results on the bar graph display. So we can see within our main code here, we're initializing the system, so that's taken from the default MCC code. We're then, as I mentioned earlier, loading lat_c with the value 0x01, so that would be this part here in the first execution. We then enter this while one loop, where we've got a short delay value. We then have lat_c being left shifted by a position of 1. So then we're going from D0 to D1. We're then reloading that new value into lat_c. We would visually see this on the bar graph display going from D0 to D1. We then also have this if statement, which only activates when the value of lat_c is 0x80. So that is when we're in our 8th execution. So this won't happen right now. So we'll go over this several times until we get to 0x80. And then at that moment, we have a short delay so that we can actually see the 0x80 value on the bar graph. And then we reload lat_c with 0x01. And then the cycle continues, starting back at 0x01. So that's how this code works. You can also left shift in 2, 3, however many spaces you like by changing it here. So for example, if we run this the first time, we start with 0x01. This would then go to 0x04. And the code will run in that way. We would be skipping 2 steps each time. But in my case, I want to keep it shifting by 1. So keep it like this. So then now we'll see the simulation. So you can see we're going in steps of 1. And you can see it's looping back. And the only reason it's doing that is because we have this if statement here. If we didn't have this if statement, what would happen would be that we will start from 0x01, continue up to pin RC7, and then the 1 would be shifted out of the register, and then there would be no more 1s left in the register to shift, so you would just be shifting the zeros. So that is the reason for the if statement. Well, that's it for today's video. I hope you found it useful. Source code and files can be found in the description below. And till the next time, goodbye.